Welcome to EDU World Space.
Okay, so this is the force diagram for the joint H. So we know the system is in equilibrium, therefore the net force along xy direction is equal to 0. So we have FEH cosine 30 degree minus FH cosine 30 degree is equal to 0 along the x direction. So this will give us FEH is equal to FFH. So now let's take a look at the net force along the y direction, which is equal to P minus FEH sine 30 degree minus FH sine 30 degree is equal to 0. And this will give us P is equal to FEH, which is equal to FFH. Since sine 30 degree is equal to 1/2. And since there are two sine 30 degree here, this will give us 1/2 times 2 is equal to 1. And this will give us P is equal to FEH and FFH. So now, since we know the crate is suspended, therefore the force P here should be equal to the gravity of the crate, which is equal to mg, and we know the mass of the crate is 150 kilograms, and the acceleration of gravity is 9.8 meters per second squared. And this will give us force P is equal to gravity, which is equal to 1470 Newton. And this will give us FEH and FFH is also equal to 1470 Newton, since they are both equal to P. So now let's take a look at the force diagram for the tongs ECA. So now let's take a moment about point C. So we have such equation here. Since counterclockwise moment is positive and the clockwise moment is negative. And if we do some arrangement here, we'll have such equation here. So the NA here is the normal force at point A, and FA here is the friction at point A. And we know the friction at point A can be equal to mu s NA. Mu s is the coefficient of the static friction we're looking for to determine in this question. So now that we can use mu s NA substitute for FA. So we have 500 NA plus 275 mu s NA is equal to FEH times 275 sine 30 degree plus 500 cosine 30 degree, since the unit here can be cancelled off. And remember, FEH is equal to 1470 Newton. So now we can plug in these values back into the equation. We'll have 500 NA plus 275 US NA is equal to such number here. So now let's take a look at the force diagram for the crates. Okay, W here is the gravity of the crate. NA and B is the normal force from point A and point B, and at each point there's a friction. So we know that since the system is in equilibrium, therefore the net force along xy direction should be equal to 0. So we have NA minus NB is equal to 0, which means that NA is equal to NB. And we have FA plus FB minus W is equal to 0. Therefore, W is equal to FA plus FB. And remember, FA can be equal to mu s NA, and FB can be equal to mu s NB, which is equal to mu s NA, since NA is equal to NB. And this will give us FA plus FB can be equal to 2FA, which is equal to 2 mu s NA, and this is equal to gravity. And then we have mu s is equal to W over 2 NA, which is equal to 1470 Newton divided by 2 NA, and this is equal to 735 Newton over NA. Remember, 500 NA plus 275 mu s NA can be equal to 654 Newton, based on the equation here. So now we can use 735 Newton over NA, substitute for mu s, and this will give us such equation here. As you can tell, NA can be cancelled out. So eventually we'll have NA is about 1273 Newton. So now we can determine the least coefficient of static friction, which is mu s here, and mu s can be equal to 735 Newton over NA, which is equal to 735 Newton over 1273 Newton, and this is equal to 0.577. And this is the answer for this question.